In the last video, we learned that an evolutionary tree is a diagram that can show homologous traits and generations of species. But not all similarities are homologies. In the game you played in video 1, you decided that some legs were not like the others. The matching limbs in the game have bones, and you eliminated the limbs that don't have bones. Since the octopus, sea star, and grasshopper limbs don't have bones, you concluded that they are probably not homologous to tetrapod limbs. Homologies are inherited from common ancestors. The octopus limb could only be homologous to the lizard limb if they both inherited the limb from a common ancestor. This tree shows how the octopus is related to tetrapods, and the points in their evolutionary histories when their limbs evolved. Tetrapod and octopus limbs evolved independently after their point of common ancestry, so they were not inherited from a common ancestor. Therefore, they are not homologous. The same is true of the grasshopper leg and the sea star arm. Simple observation tells us that these limbs are probably not homologous to the tetrapod limb, because they have such different structures. Elvis impersonators have many similarities, such as long black sideburns and rhinestone-studded suits, that are not inherited. In the same way, biological similarities are not always due to inheritance. For example, look at these skulls. They belong to extinct animals, and both of them have saber teeth. Long, ferocious canines with serrated edges. Would you guess that these saber teeth are homologous? These two skulls certainly look like the animals could have inherited their saber teeth from a common ancestor with long teeth. And the presence of teeth themselves is definitely a homology, in that the common ancestor of these two had teeth, which were passed down to these descendants. However, the unusual length of these teeth is not homologous. One skull belongs to Thylacosmolus, a close relative of marsupial mammals. The other belongs to Smilodon, the saber-toothed cat, which is a placental mammal. Marsupial and placental mammals are very different and diverged from each other a long time ago. Thylacosmolus is more closely related to marsupials such as kangaroos and koalas than it is to Smilodon. Smilodon is more closely related to other placentals such as house cats and elephants than it is to Thylacosmolus. Saber teeth are not a common trait in the marsupials closely related to Thylacosmolus, or in the placentals closely related to Smilodon. Their common ancestor certainly had teeth, but they were probably not adapted into fierce sabers. That means that one lineage on one part of the tree of life evolved saber teeth from normal-length teeth, and a different lineage somewhere else on the tree independently evolved saber teeth from normal-length teeth. This is an example of convergent evolution. Both lineages evolved saber teeth, which likely helped them kill prey. Traits that evolve separately from each other but look the same or have the same purpose are called analogous traits. Such traits are analogy, not homology.